Hello everyone, I'm Peter. Recently, these fan race cars have been really catching my attention, whether it is Brabham's Formula One car BD46 or the electric sports car McMurtry Sperling. These prototypes has proven that putting fans on the race cars to generate extra downforce is pretty effective. To be, to be honest, I've been quite envious about these successful designs, but my own resource cannot afford me to design or make a new race car. But overall, it is a pretty great opportunity for me to test whether installing fans under RC race cars could generate extra downforce and enhance its performance. Currently, I have three candidates for my fan car design. The first prototype, the vacuum. It has a ducted fan sucking air out of the area, causing pressure difference between the interior and the exterior, thus creating vacuum and downforce. The second prototype, I'll call it a ground effect tunnel. It is shaped with a narrow choke and a wide diffuser to generate downforce based on the Bernoulli principle. I'll talk about it more specifically later. The third prototype, I call it a double diffuser, which has a similar working mechanism to the second one. The main difference is that the ducted fan is sucking the air out of the tunnel in order to provide a cleaner flow. Now let's get back to the second prototype. It is basically cutting the Venturi tunnel in half. The fan accelerates the air under the tunnel and decreases the air pressure inside the choke, causing pressure difference and downforce. But why is the pressure decreased? According to the Bernoulli's equation, the sum of the pressure, kinetic energy, and the potential energy of the airflow is constant, so the sum everywhere in the tunnel is the same, and the potential energy of the flow is negligible since it is merely the same height. According to the continuity equation, the product of the flow area and the flow velocity is always constant. Therefore, when the flow in the choke gets narrower, the velocity increases, so does the kinetic energy. Since the potential energy stays unchanged, when the kinetic energy of the choke increases, the pressure decreases. When the pressure decreases, the pressure difference and the negative pressure occurs. There's a downforce. Is it really effective? Well, let the experiment tell us. I used a 3D printer to print out this ground effect tunnel. It is rather simple to me. The next step for us is to install the ducted fan in the entrance of the tunnel and its ESC controller. Well, this prototype is only producing a tiny bit of downforce, so it's probably halfway to its failure. But what's the problem? We need actual experimental data to know what problem do we have on this prototype in order to get a better design, a better version. This time, the choke is lower and the diffuser becomes wider to prevent airflow stall. This BMP280 is a pressure sensor to collect the data inside the tunnel. And lastly, an Arduino Uno board is utilized to control the sensors. Now, install the sensors and wire these things and it is ready to test. Before the fan is turned on, the barometer is collecting the atmospheric air pressure. As we can see, the pressure is around 107,336 pascals. Now, let's turn on the fan and see what is the pressure data collected in the choke. And the data shows that the pressure of the choke is around 104,600 pascals. Due to the fluctuation of various factors such as air temperature, the air pressure might be different. Currently, the air pressure collected by the barometer stays around 100,666 pascals. After we turned on the fan, the air pressure dropped to a level around 100,572 pascals. Now, it is time to perform a primitive calculation on the downforce generated. I could use the force equals pressure times area to calculate the downforce. To begin with, looking at the data, the choke has a quite big pressure difference, around 2,736 pascals, and it has a relatively small area, around 9.75 square centimeters. Thus, through calculation, the choke generates around 2.667 newtons of force. Next, the airflow condition of other places of the tunnel are similar. And to clarify, the calculation is only for approximation. So basically, the pressure difference of the other places in the tunnel can all be rounded as 94 pascals. After multiplying the two datas, we got a net force of 1.222 newtons. Therefore, the downforce of the entire tunnel is approximately 3.889 newtons, which is around the weight of 8 eggs. That is not the sufficient downforce we want.
This is the end of the video. This short experiment has proved that the ground effect concept did not produce a considerable amount of downforce and thus not enhancing the RC car performance. There might be two factors that probably affect the failure of this experiment. First, the fan is actually producing a huge amount of turbulent air into the tunnel, which ruins its efficiency. Second, I might have designed the diffuser so simple that it also reduced the productiveness of the tunnel. But there are nevertheless two remaining experiments waiting for me. This is just the beginning. I still need to experiment on the vacuum and the double diffuser prototypes. I'll keep updating my progress and hope you guys enjoy my video. See you next time.